Question number 4. Can you derive the following relationship for the dilute ideal solutions? μI solution is the chemical potential of component I in a solution. μI liquid star is the chemical potential of pure liquid I. MI solution is the molarity of component I in the solution. D is the density of water in gram per milliliter. Let's start from the equation to calculate the chemical potential of component I in the solution for ideal solutions. When we compare these two equations, this equation contains the mole fraction of component I in the solution. This equation contains molarity of component I in the solution. My guess is that if we can convert the mole fraction to molarity, then we may be able to get what we are looking for. Let's try it. Let's put down the definitions of mole fraction and molarity first. I should tell you that this ideal solution is an aqueous solution. Therefore, the solvent is water. As we know, the concentration does not depend on how many liters of solution we have. That will give us a very convenient way to solve the problem. Let's assume we have 1 liter of solution. But I want to emphasize, you can also assume that you have 2 liters or 10 liters of solutions. It does not matter what volume or how many liters you choose. But if you choose 1 liter, the calculation may be a little easier than you choose the other numbers. If we assume 1 liter solution, we can calculate the moles of component I from the definition of molarity. I put on the unit inside the parenthesis. Then liter will cancel. We can get MI solution moles of solute I. Let me put the unit inside the parenthesis. Because this is a dilute solution, that means we have a lot less solute than water. Well, in that case, we can assume that the mass of water is approximately equal to the mass of solution. We can also assume that the moles of the solute should be much less than the moles of water. The mass of the solution can be calculated by using the density of water and the volume of the solution. Because it is a dilute solution, the density of water is roughly equal to the density of the solution. This is milliliter, this is liter. Therefore, we need another conversion factor. Then we can get the mass of solution and also is the mass of water. The unit is G. To avoid any confusion, I put the unit inside the parenthesis. As I said a moment ago, we can assume that the moles of solute is much less than the moles of water. I'm running out of space. Let's calculate the moles of water from the mass of water by using the molecular weight of water. Then we can plug the moles of component I and the moles of water into this equation. Then let's see what we get from the mole fraction of component I. Remember, we neglect moles of solute. Let's use this expression to replace Xi solution because these two are equal to each other. Because natural log A times B is equal to natural log A plus natural log B. By using this relationship, let's separate these two terms. Then we can use the law of distribution to separate this into two terms. We can switch the order of these two terms. We will get what we are looking for. Let's compare what we get to what we are looking for. Say if they are exactly the same. Are they the same? Actually, they look exactly the same.